brace yourselves for a cosmic cataclysm of unprecedented proportions, because Betelgeuse, the massive red giant star near the edge of our galaxy, is sending ominous signals across the universe. Using the James Webb Space Telescope, astronomers have uncovered unsettling evidence about this colossal celestial body, prompting renowned astrophysicist Brian Cox to warn that we may be on the brink of witnessing a catastrophic supernova that could forever change the night sky. In the vast tapestry of the cosmos, where stars are born, live, and die in spectacular ways, Betelgeuse has captured both scientific and public attention like no other. Situated in the constellation Orion, this red supergiant is famed for its distinctive reddish hue and shifting brightness, but recent developments suggest we are on the cusp of a monumental event in its life cycle. At roughly 764 times the size of our Sun, Betelgeuse is so immense that if placed in our solar system, it would engulf Mercury, Venus, Earth, and Mars, stretching past the orbit of Mars itself. This staggering scale reflects its twilight phase as a red supergiant, the inevitable result of millions of years of nuclear fusion gradually exhausting its hydrogen core. Though only 8 to 8.5 million years old, a blink in cosmic terms, Betelgeuse is already ancient in the life cycle of massive stars, having evolved from a hot blue star into the cooler, swollen red giant we see today. Its surface temperature, at about 3,500 Kelvin compared to our Sun's 5,500 Kelvin, gives it that unmistakable red glow, a visual clue to its changing internal processes. Historical records reveal its mystique even further. Roman and Chinese texts suggest Betelgeuse once appeared yellow, while Arabic scholars in the 9th century first described it as red, marking a visible step in its stellar evolution. Its semi-regular variability, brightening and dimming in cycles of 400 days and roughly 5 years, noted as early as 1836 by Sir John Herschel and even preserved in Aboriginal oral traditions, adds to its enigmatic reputation. Yet Betelgeuse does not always follow predictable rhythms, occasionally breaking from its patterns in ways that defy explanation. This unpredictability stunned the world in late 2019 during the now famous Great Dimming, when the star's brightness plummeted dramatically, dropping at an average rate of 0.01 magnitudes per day until it reached its faintest point in February 2020. Normally one of the brightest stars in the night sky, visible even in polluted cities, Betelgeuse dimmed so drastically that amateur stargazers could see the change with the naked eye. But here lies the greatest challenge of all, the paradox of time. Because Betelgeuse is over 640 light-years away, everything we see happening now actually took place centuries ago, meaning its fate, whether steady or already collapsed, may already be sealed, waiting only for its light to reach us. When we observe Betelgeuse, we are not seeing it as it exists today, but rather as it was nearly 7 centuries ago, since the star lies about 725 light-years away, and its light takes that long to reach us. This time lag creates a profound challenge in monitoring sudden stellar changes, as astronomers are essentially peering into the past. The dramatic dimming of Betelgeuse served as a stark reminder of this time paradox and the inherent limitations of real-time, astronomical observations. The unfolding of this celestial mystery was closely studied by Andrea Dupree, Associate Director of the Center for Astrophysics at Harvard and Smithsonian, and her team, who used the Hubble Space Telescope as part of a 3-year study to monitor variations in Betelgeuse's outer atmosphere. Hubble's ultraviolet sensitivity enabled researchers to probe the heated layers above the star's surface, revealing turbulent convection cells and streams of material moving outward at incredible speeds of nearly 200,000 miles per hour. By analyzing magnesium-2 spectral lines collected throughout 2019 and 2020, the team discovered that a massive outburst from Betelgeuse's southern hemisphere ejected roughly twice its normal amount of stellar material. This hot, dense matter expanded millions of miles outward and eventually cooled into a dust cloud, obscuring nearly a quarter of the star's surface and causing its dramatic dimming. The scale of this event raised questions about whether it could be a prelude to a supernova, especially given Betelgeuse's proximity to Earth, where such an explosion would appear dazzlingly bright in the sky. Yet astronomers debated alternative explanations, including a sudden change in the star's photosphere or a massive surface dark spot that temporarily lowered its temperature by about 170 Kelvin. Ultimately, Hubble's ultraviolet light observations provided the strongest evidence, showing that the dimming was most likely caused by an enormous ejection of superheated plasma that cooled into dust grains as it moved outward. Ground-based telescopes confirmed the star's fading by December 2019, aligning with Hubble's findings and completing the timeline of events leading to Betelgeuse's great dimming. The dramatic outburst from Betelgeuse, particularly in its southern hemisphere, released material so luminous at first that it outshone the star's usual brightness before cooling and forming a dark cloud, which obscured part of the star and caused its mysterious dimming. The magnitude of this ejection was extraordinary, an estimated 400 billion times the mass typically expelled in a standard coronal mass ejection, weighing several times as much as Earth's moon. Such a monumental release of matter not only propelled Betelgeuse into the astronomical spotlight, but also forced scientists to rethink long-held theories of stellar evolution. Traditionally, red supergiants were thought to shed mass at a steady pace before their explosive deaths, but this unprecedented ejection suggested a far more turbulent and unpredictable end-of-life phase. Could Betelgeuse be preparing for its final act, a spectacular supernova in the next few millennia, or perhaps even within decades? The question has become central to astronomical debate. Adding to the intrigue, Betelgeuse hurtles through space at 67,000 miles per hour, generating a dramatic bow shock as its outer layers slam into surrounding interstellar gas and dust, much like a ship's bow carving waves in water. This interaction not only reflects the star's dynamic instability, but also provides vital clues about stellar mass loss. Following the ejection, Betelgeuse's surface cooled and thinned, leaving the star in an unstable state that continues to puzzle astronomers. Hydrodynamic simulations reveal a possible link between convective activity, massive outbursts, and changes in its pulsation cycles, underscoring how chaotic its interior processes may be. Observations also show that Betelgeuse's mass loss rate is far greater than most stars, driven by powerful pulsations and shock heating that fuel repeated eruptions. These revelations raise the unsettling possibility that Betelgeuse's fate may be closer than once thought. As the astronomical community debates its ultimate destiny, attention was drawn to a fresh cosmic event that offered a vivid point of comparison: supernova SN 2023X in the Pinwheel Galaxy, Messier 101, just 21 million light-years away. Discovered in May 2023 by Japanese amateur astronomer Koichi Itagaki using a modest 0.35-meter telescope, this supernova quickly became one of the closest and most studied in years. Within days, telescopes across Earth and in orbit, including Hubble, raced to track its evolution. The data gathered on SN 2023X's rapid rise to peak brightness in just 5 days, followed by a gradual dimming, provided an invaluable window into the cataclysmic finale of a massive star, a process Betelgeuse itself may one day replicate, perhaps sooner than we once imagined. SN 2023X's dramatic light curve revealed a daily dimming of 0.03 magnitudes, while spectral analysis uncovered a wealth of bright emission lines, evidence of the violent clash between its expanding shockwave and surrounding gas. This was no ordinary stellar death, but a massive star collapsing under its own weight as nuclear fuel ran out, its outer layers rebounding off a dense core in a spectacular core collapse supernova. What made SN 2023X particularly fascinating was the dense shell of circumstellar gas enveloping it, which slowed the shockwave's escape. Astronomers suggest this material was shed either by a steady, powerful wind or by violent, random outbursts, with the star losing as much as a solar mass in its final 1 to 2 years, proof that its last days were turbulent, not tranquil. Identifying the progenitor has become a key pursuit, with evidence pointing to a red supergiant. By studying this explosion's details, its progenitor, its mass loss, and its mechanics, astronomers refine their models of stellar evolution and supernova physics, insights that directly inform what Betelgeuse's future may hold. The question of Betelgeuse's fate looms large. Is it nearing its end now, or does it still have millennia left? Research from Japan's Tohoku University suggests Betelgeuse may already be in the carbon-burning stage, a precursor to collapse within decades, while Hungary's Konkoly Observatory posits it is still in the earlier helium-burning phase. Despite these disagreements, most agree it is the Milky Way's most likely candidate for the next nearby supernova, though the event could still be as far as 100,000 years away. History shows us that such events have captivated humanity for millennia, from the supernova of 185 CE, which shone for 8 months, to SN 1006, the brightest stellar event ever observed, to SN 1054, which gave birth to the Crab Nebula and remained visible in daylight for 23 days. Kepler's SN 1604 remains the last in our own galaxy, while 1987A in the Large Magellanic Cloud became the first supernova captured through neutrinos and across the entire electromagnetic spectrum. These milestones have transformed our understanding of stellar deaths and their role in seeding the cosmos with heavy elements. So, what would it mean if Betelgeuse suddenly erupted? Its explosion would be a core collapse supernova of staggering energy, releasing in seconds as much power as our sun will emit over its entire 10 billion-year life. The light show would be breathtaking, outshining the moon, visible even in daylight, perhaps resembling a second sun for weeks or months. Beyond the spectacle, the event would offer a rare scientific treasure, a chance to study the final stages of stellar evolution up close, including how such explosions scatter heavy elements like iron, the very building blocks of planets and life, into the cosmos. Spectroscopic data would track this elemental dispersal, while neutrinos produced in vast numbers would carry clues from the collapsing core itself, offering insights into fundamental forces and extreme physics. Such an event could also refine our grasp of cosmic expansion and dark energy, much as distant supernovae once revealed the universe's accelerating growth. And yet, despite its drama, Betelgeuse poses no real danger to Earth. At 725 light-years away, over 4,267 trillion miles, the star is far enough that its radiation cannot harm us, serving only as a cosmic performance on a scale rarely witnessed by humanity. When it comes, Betelgeuse's supernova will not threaten our planet, but will forever reshape our night sky and deepen our understanding of the universe.